Hello, this is Mrs. Huntley. We are in Module 1, Lesson 1, and we are going to be studying about exponential notation. We started in class today looking at some vocabulary. If you were not in class today or you did not complete the vocabulary, we're actually going to start on the inside cover of your module. If you were in class today and you are confident that you got everything down and that it's all correct, you may fast forward in the video. I think it's about 4 or 5 minutes that I spend talking about the vocabulary. If you weren't sure that you got everything down, you might want to just rewatch it, make sure that your notes are complete. So you should have 6 post-it notes posted on the inside cover of your module. Have the sticky part to the top so that you can flip them up. And when you flip up the post-it note, you are going to write the definition on the back of the post-it note and then have an example under where the post-it note covers on the back cover when it's flipped down so that you can be working with these words and testing yourself. So the first one, exponential notation. What is exponential notation? It's a math shorthand to show repeated multiplication. The example we used in class today was 3 to the 4th power. So if I have 3 to the 4th power, what does it mean? It means 3 times 3 times 3 times 3. It's easier to write 3 with a little raised 4 above it than it is to write 3 times 3 times 3 times 3. It just gets a little bit cumbersome if we write it over and over again. Next one, base. The base is the number or variable that's being raised to the power. It's the big number, and I have big in quotations here because I don't mean it's big in value. It's the one that's larger. So in our example, 3 to the 4th power, 3 is the base. Similarly, exponent and power, I've been using them interchangeably on this video as I was in class today. Exponent and power mean the same thing. We say 3 to the 4th power, 4 is the exponent. It's the little number that tells us how many times to multiply the base by itself. So again, 3 to the 4th power, the 4 is the exponent. The next one, square and perfect square, these are not synonyms, but we're going to define both of them. A square is a number raised to the 2nd power. If we raise a number to the 2nd power, we say it's squared. So if I have 3 to the 2nd power, I would say 3 squared. A perfect square is the product. And if you remember, product is what you get after you multiply something together. So 3 times 3 is what 3 squared means, and that's 9. And 9 is the perfect square here. Now, any number can be squared. It's the product that's actually a perfect square, and not every number is a perfect square. For example, if we take 2 squared, that's 4. 3 squared is 9. 4 squared is 16. Now there are numbers, integers, counting numbers that come between 4, 9, and 16. Does that mean they're not good numbers? No, it doesn't mean that they're not good numbers. It just means that there's no integer multiplied by itself that will equal 5 or 6 or 7. So that, all of the numbers that come between 4 and 9, they're fine numbers. They're just not perfect squares. The next one, cube and perfect cube. It's very similar. If we cube something, we're raising it to the 3rd power. So if I have 3 to the 3rd power, I say 3 cubed. And what does it mean? It means 3 times 3 times 3. 3 times 3 times 3 is 27. And 27 would be the perfect cube. Very similarly, any number can be cubed. Like 2 cubed, 2 times 2 times 2. 2 times 2 times 2 is 8. And we already did 3 cubed. And that's 27. There's a lot of numbers that come between 8 and 27. They're fine numbers, they're just not perfect cubes. Expanded form. Expanded form we've been dealing with all along here. It's an expression written out longhand, just like I did right over here. So it's exponential if you've got, going back to our original example, 3 to the 4th power. It's expanded form if you expand that out and say 3 times 3 times 3 times 3. I use that as a vocabulary word only because in directions you might see where it says write this in expanded form or write it in exponential notation, and I wanted to make sure you knew the difference between those words. So vocabulary is done. Again, if you were in class today, this is a review. If you were not in class today, you're going to want to have those 6 post-it notes on the inside cover of your module. Right now, I'd like you to turn to page 2 in your module, and we're actually going to start the lesson now. So on page 2, your essential questions. How do I write numbers in exponential notation, and what are some benefits? So the first example is 5 times 5 times 5 times 5 times 5 times 5. So we know 5 is being multiplied by itself. So that's our base. We're going to write a base of 5. How many times is it being multiplied by itself? That's going to be our exponent. So 1, 2, 3, 4, 5, 6. So this is going to be 5 to the 6th power. In example 2, we have 9 sevenths being multiplied by itself. 9 sevenths times 9 sevenths times 9 sevenths times 9 sevenths. So we're going to write 9 sevenths. It's being multiplied by itself 1, 2, 3, 4 times. But if I write it like that, I don't know if the 4 is being applied to the 9 or the 7 or both. So what I need to do when I have any fraction, I need to make sure I put a parenthesis around it so I know that that 4 is being applied to both the 9 and the 7. The exponent should be on the outside of the parentheses so that I know it is being applied to both 9 and it's being applied to the 7. Okay? The next example, I have negative 4/11 to the 3rd power. And they want us to write it in expanded form. If they're giving it to you in exponential form, they want you to write it in expanded. If it's in expanded form, they want you to write it in exponential. So negative 4/11. First of all, we've got a fraction here, and we have a negative sign. So I'm going to use parentheses to make sure that everything stays together, that I don't drop any of the pieces. I like to think, I told you before, I have some weird idiosyncrasies when I'm doing math, and I like to personify things, and I think of parentheses as little hands holding everything together inside so that nothing falls out. So I'm going to multiply negative 4/11 times negative 4/11 times negative 4/11. Now the cool thing is when you're multiplying something by itself, in algebra or by itself, if you have parentheses, it's assumed that it's multiplication in there. You don't have to put a little multiplication sign in between any of them. So I like parentheses just sometimes for the sake of not then having to put a dot in between or to do anything else that will make me know that I'm multiplying. Example 4, negative 2 raised to the 6th power. Again, I'm going to want to use parentheses here to make sure I hold that negative sign on my 2. Because negative 2 raised to the 6th power in parentheses is much different than negative 2 raised to the 6th power without those parentheses. So negative 2 times negative 2 times negative 2. Oh golly, I have to do this 6 times. Oops. And of course then I say the number 6 and I write it. So negative 2, 1, 2, 3, 4, 5, 6. Ah! Yes, you're making fun of me right now. I know, that's okay. Do you see one of the benefits already of using exponential notation? Writing all those negative 2's was difficult for me. I know it's not going to be difficult for most people, but it certainly was for me. Okay, now we have example 5. 3 8/10 raised to the 4th power. When I have a decimal, I'm again going to encourage you to use parentheses, not because you have to make sure that everything sticks together, but just because you don't want to get confused. Now don't write this down, but I'm going to show you an example. If I write 3.8 times 3.8 times 3.8, there's a lot of dots in there, and it's confusing as far as what is the decimal and what is a multiplication sign. So in order to not be confused or not write something that somebody's not going to be able to decipher, I'm going to use some parentheses and say 3.8 times 3.8 times 3.8 times 3. I should say 3 8/10. I apologize for using improper math grammar. So that's how I would write these in either exponential notation or expanded notation. So down below, if n is a positive integer, then 3 raised to the nth power means 3 multiplied by itself n times, whatever n is. And they're either going to give us n or we're going to have to solve and figure out what n is. Like if this was an equation and it said 3 to the n equals 9, then I could solve for what n would be, what exponent n would be. Negative 2 to the n means, again, negative 2 is going to be in parentheses, multiplied by itself n times, whatever n comes out to be. 7 8/10 raised to the nth power. Again, we've got those parentheses, so I know the whole thing is being multiplied by itself n times. If we had something like this, and don't write this down, I'm just giving you the example. If we had 7/8 raised to the nth power with no parentheses, it would mean, actually you can write this down, it would mean 7 times it's multiplied by itself n times divided by 8. The exponent would be applied only to the 7, not to the 8. So it wouldn't be 7/8 times itself over and over again. It would be 7 times itself over and over again divided by 8. So it means very different things. The next one, x to the n, is called x raised to the nth power. That's how I would say that in words. If I was trying to say this, so I would say x raised to the nth power. And again, I don't know what n is. It's just getting used to notation. What does it mean? It means, whoops, I forgot one apparently. N is the exponent, just go in there. So what does it mean? It means, let me get to where I can type. I'm sorry, I thought this was all prepared. It means x multiplied by itself n times. Okay, so if n is the exponent, we know x is going to be the base there. So again, this is just getting you used to the vocabulary, used to what's going on as far as, looking at the exponential notation. These on your own exercises, why don't you go ahead and pause the video, see if you can tackle, why don't you do 1 through 5 on this left side and then come back and check your work, because I see we're getting kind of tight on time already. So do 1 through 5 right now, pause the video, and then come back and check your work. Okay, I have the answer. So 4 times 4 times 4 times 4, 7 times is 4 to the 7th power. 3.6 or 3 6/10 times 3 6/10 times 3 6/10 all the way to, or if it equals 3 6/10 raised to the 47th power, that means I am multiplying it by itself 47 times. Exercise 3, if I have negative 11 and 63/100ths and I'm multiplying it by itself 34 times, I would make sure I have to have those parentheses and I'm raising it to the 34th power. Exercise 4, we've got a 15 here, so that means I'm multiplying 12 times itself 15 times. Exercise 5, I've got a 10 here, that means I'm taking that negative 5, I need the parentheses there, and I'm raising it to the 10th power. Well, I think you probably heard the bell ring, and we are at almost 15 minutes. So for our first recording, I think that's going to be sufficient, even though I didn't get as far in the lesson as I was hoping to. We will complete the lesson in class tomorrow. And actually, what I'd like you to do, go ahead and try to do exercise 6 through 10. We'll correct those first things in class tomorrow. Then we'll finish page number 4 and then 4 and 5, and I'll give you the assignment. So I hope you have a good night. I hope this worked well for you, and I look forward to seeing you in class tomorrow. Bye.